In this video, we're going to focus on using matrices to solve simultaneous equations. And we have two examples that we're going to use to illustrate this concept. So let us start with the first one. So we have x plus y is equal to 7 and 2x minus y is equal to 5. The first thing you're going to do is just write this set of simultaneous equations in form of matrices, where the first matrix is going to be composed of the coefficients, and the second one will be the unknowns, and then the last one will be the results or the right-hand side of that particular equation. So the coefficient will be 1, 1, 2, negative 1, then we have x and you have y, then that should be the same as 5, or not 5 but 7, 5, 7, 5. So let's go ahead and label these matrices A, X, and B. So the unknown matrix is represented by X, but you realize that you can get X by taking B over A, which is the same as A power negative 1 B. In the real sense, this is just the inverse of the matrix A. That is the coefficient matrix. So for us to get X, we just pre-multiply B by the inverse of the matrix A. So let us go ahead and do that. So let us start by getting the inverse of the matrix A. So remember that inverse of a matrix A, the inverse of matrix A is obtained by taking 1 over the determinant of that matrix, then multiplying by the adjoint of that matrix A. So let's go ahead and obtain these two, the determinant and the adjoint. So the determinant of matrix A is given by the product of the main diagonal, that is 1 times negative 1, that is negative 1, minus the product of the other diagonal, that is 1 times 2, that is 2. So you'll find that that is equal to minus 1 minus 2 is minus 3. The determinant is minus 3. Now the adjoint of the matrix A is obtained by switching the members of the main diagonal. That is, instead of 1, negative 1, you're going to have negative 1, 1, and then changing the signs of the other diagonal, like that. So now, it means therefore that the inverse of A is given by 1 over the determinant times the adjoint, which you have obtained to be negative 1, negative 1, negative 2, 1. That is the inverse. You could open it up or you could use it the way it is. So let us go ahead and rewrite the equation that we now want to solve. So what we have now is X, and remember X was representing XY, the matrix, and then we're taking the inverse of A, which we have obtained to be negative a third into negative 1, negative 1, negative 2, 1, and then we are multiplying it by B. And what was B? B was the results or the values we had on the right hand side. That was 7, 5. So let us go ahead and use that. So we multiply this by the results, that is 7, 5. So we can first of all multiply the two matrices before we use the scalar, which is negative a third. So we are going to have negative a third into negative 1 times 7 plus negative 1 times 5, and then we have negative 2 times 7 plus 1 times 5. So that is the same as negative a third into negative 1 times 7 is negative 7 minus 5. Then down here we have minus 14 plus 5. So let us simplify this down here. So we have that x, y, the matrix, is equal to negative a third into, now we have minus 7 minus 5 is minus 12, and minus 14 plus 5 is minus 9. So when we do that, we multiply negative a third times 12, we get 4. We multiply negative a third times negative 9, we get 3. So this implies that the values of x, the value of x is 4, and the value of y is 3. So that is the first example that we have. Now let us look at the second example. The second example was 3x plus y is equal to 9, and 2x minus 3y is equal to negative 5. So as we did it the first time, we just write these in matrix form, where the first one is the coefficients of these variables in the left. So we have 3, 1, 2, negative 3. And then the next matrix is that of the variables or the unknowns, that is x and y. And then on the right we have 9, negative 5. So as we said, for you to get the value of x, y, the unknown matrix, you're just going to take the inverse of the coefficient matrix, the one we label as A, times the result. So we're going to take the inverse of A times B. So let us go ahead and do that. So it means the first thing you're going to need is the inverse of the matrix A. So for us to get, we say that the inverse of matrix A is given by 1 over the determinant of A times the adjoint of A. So we can get these two information. So the determinant of A will be given by the product of the main diagonal, that is 3 times negative 3, which is negative 9, minus the other diagonal, 1 times 2, which is just 2. And you want to find that to be equal to minus 11. That is the determinant. And then the adjoint of the matrix A, just switch the members of the main diagonal so that you have negative 3 and 3, and change the sign of the members of the other diagonal. So now the inverse of A is negative 1 over 11 into negative 3, negative 1, negative 2, and 3. So we have the inverse. We can just get the unknowns. So remember, we can get the unknowns, that is x, y, the matrix, is going to be equal to the inverse of A, which you have found to be this one, that is minus 1 over 11 into negative 3, negative 1, negative 2, 3, times B. B was the one on the right hand side, that is 9, negative 5. So we multiply what we have there by 9, that is 9, negative 5. So let us go ahead and do that. So we have negative 1 over 11 into negative 3 times 9 plus negative 1 times negative 5. Then we have negative 2 times 9 plus 3 times negative 5. So let us simplify this. So when you simplify this, we're going to have minus 1 over 11 into negative 3 times 9 is negative 27 plus negative 1 times negative 5, that is plus 5. Then here we have negative 2 times 9, that is negative 18, plus 3 times negative 5, that is minus 15. So let us simplify this. We have negative 1 over 11 into minus 27 plus 5 is the same as minus 22. Then minus 18 minus 15 is the same as minus 33. So when we open up and we multiply by this color, we're going to find that our matrix xy is equal to minus 1 over 11 times minus 22 is 2, and minus 1 over 11 times minus 33 is 3. This implies that x is equal to 2 and y is equal to 3. Thank you for watching. Kindly subscribe.